orbiter could also observe the event. Both missions have scientific teams that routinely release data, though not always immediately. The participation of these missions would expand global coverage and help compensate for NASA's temporary inactivity. The NASA shutdown affecting about 1.5 million government employees has generated widespread uncertainty about ongoing projects. Some missions are deemed essential and continue operating autonomously, but many communication and analysis functions are paused. This means that even if spacecraft collect images or data, they may not be processed or released until the shutdown ends. The situation highlights how fragile the coordination of space science can be. While probes continue to function, the flow of information to the public and the scientific community can be abruptly interrupted by domestic politics. The coincidence of this administrative disruption with a close approach of a rare interstellar object underscores a systemic vulnerability in how scientific discovery depends on governmental continuity. In the absence of official updates, amateur astronomers and independent analysts have played an essential role in monitoring 3 Atlas. Using publicly available telescope networks and open data, they have managed to capture imagery, calculate orbital updates, and track changes in brightness. This decentralized approach reflects a broader trend in modern astronomy, where professional and citizen scientists collaborate in near real time through forums, social media, and data-sharing platforms. Observations are cross-verified and refined. This cooperative model has allowed information about 3 Atlas to circulate even as institutional channels remain quiet as the object continues inward toward its perihelion later in October. Scientists are closely modeling its potential evolution. If 3 Atlas behaves like a typical comet, solar heating could cause increased outgassing, possibly expanding its coma further or creating temporary jets of material. However, given its anomalous behavior so far, predictions remain uncertain. Its structural integrity and unusual emission patterns suggest it may respond differently to solar radiation than any comet previously observed. Some models propose that its high speed and composition could prevent significant disintegration, allowing it to survive perihelion intact before continuing on a hyperbolic trajectory out of the solar system. Its approach to Mars provides another unique opportunity. While it is not expected to have any physical impact or visible interaction with the planet, the possibility of subtle magnetic or atmospheric effects is of interest. Mars's thin atmosphere and weak magnetic field could register disturbances from the passage of a large ionized object in its proximity. Instruments on orbiters and rovers may detect transient changes in charged particle densities or solar wind interactions, offering indirect measurements of 3 Atlas's plasma environment. From a scientific standpoint, interstellar objects like 3 Atlas are valuable because they carry material formed around other stars. Each one that enters our solar system represents a sample of distant planetary systems, offering clues about their chemistry and history. The 2 previous known examples, Oumuamua in 2017 and 2 Borisov in 2019, demonstrated that such visitors are more common than once believed. Oumuamua, with its elongated shape and unexplained acceleration, inspired hypotheses ranging from natural fragmentation to alien engineering. Borisov resembled a conventional comet, but displayed different compositional ratios, confirming that material from other star systems can enter ours. 3 Atlas, larger and more complex than either, could provide an even clearer understanding of interstellar matter. The observations being conducted now are expected to yield data on the object's composition, rotation, albedo, and possible outgassing patterns. Spectroscopic analysis from Mars orbiters may reveal the presence of carbon compounds, ices, and metallic elements. If 3I Atlas exhibits emission lines inconsistent with known cometary materials, that would indicate unfamiliar chemistry or surface processes. The collected data, once combined across missions, could establish whether interstellar objects form under similar conditions to those in our own solar system or reflect entirely different environmental histories. For the general public, the idea of an object from another star passing near our planetary neighbor is inherently compelling. It reminds humanity of its small but expanding awareness in a galaxy filled with motion and change. The fact that such a significant event can unfold while official channels are silenced by bureaucratic dysfunction emphasizes the disconnect between cosmic and political timescales. The universe continues regardless of institutional schedules, and discoveries depend on maintaining consistent access to the sky. As of now, the last available Earth-based image of 3 Atlas taken on October 2nd still shows its distinctive diffuse coma and layered internal structure. Its outer shell appears faint and extended, while its inner region remains brighter and denser, possibly corresponding to a nucleus several kiloohm wide. The coma's gradient coloration may be the result of varying ionization levels within its gaseous envelope. Continued heating from the sun is expected to enhance its activity, though not necessarily in the same way as other comets. When 3ie Atlas reaches its perihelion, it will likely be traveling at its maximum speed of about 68 kilometers per second. After that, it will begin its outward journey, eventually crossing Jupiter's orbit. The European Space Ice Juice mission will attempt to record its behavior from that vantage point. However, due to communication constraints, those observations will not be accessible to researchers until early 2026. At that point, the object will be moving away from the sun and gradually fading from view. Within a few months, it will disappear beyond the reach of even the most powerful telescopes, returning to interstellar space, possibly never to be seen again. Despite the communication challenges caused by the NASA shutdown, scientists remain committed to tracking and analyzing every available piece of data. Independent astronomers continue to submit observations to open databases, ensuring that the event is documented for future study. The eventual compilation of datasets from Mars, Earth, and interplanetary missions will allow researchers to perform comparative analysis across instruments and wavelengths, producing the most detailed portrait yet of an interstellar object within our solar system. The temporary silence from NASA underscores an important lesson about the interdependence of modern science. While space agencies operate autonomously, their discoveries are interconnected. Interruptions to one nation's communication channels can delay global understanding of cosmic phenomena. At the same time, the participation of other space programs demonstrates the strength of international collaboration in maintaining continuity of discovery. 3 Atlas, whether it proves to be an unusually stable comet or an entirely new category of interstellar body, has already advanced scientific understanding simply by existing within view of our instruments. Each observation contributes to refining models of how material travels between star systems, how it survives long exposure to cosmic radiation, and how it interacts with solar environments when passing through another system. As technology improves and surveys expand, more such objects are expected to be detected. Each will provide another data point in the study of galactic chemistry and the dynamics of planetary formation. For now, 3 Atlas continues on its course. An emissary from elsewhere traveling through the domain of Mars while human observers work through administrative and technical obstacles to record its passage. The timing is inconvenient, but also symbolic. The universe proceeds independently of human schedules, and scientific inquiry must adapt accordingly. Even amid shutdowns and communication blackouts, the flow of data continues through those determined to observe, analyze, and share. The story of 3 Atlas represents more than a single astronomical event. It is an illustration of persistence in the face of uncertainty, of decentralized observation compensating for institutional delay, and of a collective desire to understand phenomena that transcend human boundaries. Whether 3 Atlas ultimately resembles a comet, an asteroid, or something yet unclassified, its presence near Mars provides an invaluable opportunity to study an object forged around another star. The coming months will reveal more through the combined efforts of scientists worldwide. But even now, it stands as a reminder that the universe's motion continues regardless of political pause or planetary concern. As this interstellar object moves past Mars and toward the outer reaches of the solar system, it leaves behind both data and perspective, a record of cosmic motion that endures long after temporary silence on Earth fades.